For this video, we're going to focus on solving exponential and logarithmic equations. We will cover two techniques on how to solve exponential equations, two techniques on how to solve logarithmic equations. So let's jump straight into it. When we're talking about an exponential equation, we're talking about an equation in the form a to the x is equal to so and so. So one of the first techniques that we're going to use actually is number one here, is we're going to use the same base rule for exponents, which says if our bases are the same, we can then set the exponents equal to each other. So jumping directly into this first example here, we need to solve the equation 3 to the x power is equal to 243. So using the same base rule, we need to figure out, well, we have a base of a 3, we have a base of a 243, and we need to figure out how would we make these bases be the same thing. Now, considering that this number here is a 3, and it's extremely difficult to change 3 into any other number, my hope is that 243 is some form of 3 to some power, and it does actually happen to be so. 243 is the same thing as 3 to the 5th power, right? Throw that in your calculator, you'll see that they equal each other. So this is exactly what I'm going to use for this example here. I'm going to drop down that 3 to the x, and instead of 243, I'm going to say that that is 3 to the 5th. Now this is all I need to do to solve this problem. Once I have it in this form, we can now use the same base rule for exponents that says if our bases are the same, which they are both a 3, we can then set our exponents equal to each other. So that means x is a 5, equation solved. And we can see here, if we did 3 to the 5th, that is equal to 243. So that is correct. When we take a look at our next example here, we are dealing with 8 to the x is equal to 4. So we need to figure out how do we get our bases to be the same thing. Now, 4 to some power does not give me an 8, right? So we might need to do just a little bit of playing around with this problem here to figure out how to get these same bases. What I can do, though, because they are both even numbers, that makes me think of 2's. And if I take an 8 actually does happen to be 2 to the 3rd power. And that 8 is being raised to the x. All right, so all I've done is take this 8, replace it with 2 cubed, and then it's still being raised to the x power. On the right-hand side, that 4, well, I'm just going to turn that 4 into a 2 squared. Right, 2 squared is equal to 4. Now, I can't quite use the same base rule yet. I don't have the same bases yet. The base on the left is 2 cubed. The base on the right is just a 2. I need both of them to be a 2, so I need to do some simplifying, specifically here on the left-hand side. Keep in mind that one of the power rules for exponents says that if we have a power raised to a power, it is asking us to multiply. So this 2 cubed then raised to the x is the same thing as 2 to the 3x. Just multiply the 3 times the x together to get this. So now we have the same bases. We have 2 to the 3x, we have 2 squared, and now we can use that same base rule. Our bases are the same, so we can set our exponents equal to each other. That means 3x is equal to a 2, and when we solve for x, we do get that x is equal to 2/3. You can verify that in your calculator. You can go ahead and type in 8 to the 2/3. You should be getting a 4 there. Now in our next example here, we have 7 times 3 to the x plus 1 is equal to 11. Now typically when you're dealing with exponential equations, you do want your exponential portion to be completely by itself. So the 7 here in front, we do want to go ahead and divide it out on each side so that it cancels on the left, and the right-hand side is now an 11/7. Now, there's two typical ways to solve an exponential equation. To get the same bases, which we just did. Now, if we take a look here, our base on the left side is a 3. Our base on the right side would be 11/7, right, raised to the 1st. Now, I don't know about you, but this does not seem very probable to get these to be the same bases, to turn a 3 into an 11/7 or to turn an 11/7 into a 3. And sometimes we're given an exponential equation where it's just not going to work out nice and pretty to get the same bases. So technique 2 of solving exponential equations, you can take the log of each side. Now, rules of taking the logs of each side. We're either going to take the common log or we are going to take the natural log of each side. You're going to use the natural log if your base is anything other than a 10. If your base is a 10, then you're going to take the common log of each side. So otherwise, your most common form here, again, your natural log, you're going to take the ln of each side. So in a nutshell, if you can't get the two bases to be the same, take the ln of each side, the ln or the log of each side, just depending on what your base is. Again, if your bases are anything other than a 10, you are going to be taking the ln of each side. So ln of the left, ln of the right-hand side. Now, the reason why we want to do that is because we want to use the power rule then. By taking the log of each side, this allows us to use the power rule for logs that says any exponent here is then going to come down in front as a coefficient. So that's going to look like x plus 1. ln of 3 is equal to ln of the 11/7. And we can solve this equation. Now we need to do some cleanup on the left-hand side. We need to go ahead and multiply that ln 3 by everything. So that's going to be x times the ln 3 plus 1 times ln 3 is just ln 3. And that's going to equal that right-hand side, ln of 11/7. So I'm going to go ahead and move this equation up here just so I have a little bit room to work with it. After this point there, though, so we divided the 7 so that we can have our exponent by itself, which we then took the natural log of each side so that we can use that power rule to bring that down in front. The rest of this is just cleanup, distributing that left-hand side and then focusing on solving for x. So the first thing we want to do is subtract ln 3 on each side to get x ln 3 is equal to ln of 11/7 minus ln of 3. We want to get x by itself by dividing both sides by ln 3. So x is equal to what we get when we type all of that into a calculator. Now, this second technique for solving exponential equations, you must have a scientific calculator in order to plug that in. When we do type that into the calculator, we do get that this is going to equal a negative 0.589 when we round to 2 decimal places as our solution for this exponential equation. Now for our next example, it did not print out here correctly in its format, so this is what the equation is supposed to look like. 3 to the x plus 1 is equal to 2 to the 2x. Again, when it comes to exponential equations, you either want to create same bases or you want to take the log of each side. Now, once again, it's not easy to turn a 2 into a 3 or a 3 into a 2. So we are going to take the natural log of each side. Again, our bases are a number that's not a 10, so we will take the ln of each side. When we do that, again, it allows us to use the power rule for logs that will now bring down that x plus 1 in front. So we have that x plus 1 ln 3 is equal to this 2x ln 2. Solve this equation for x. Let's do some cleanup on the left-hand side. X times ln 3 is x ln 3. 1 times ln 3 is just an ln 3. Is equal to that right-hand side, 2x ln 2. Now we do need to solve for x. Do notice that we have two x's in our problem here. So two terms that have an x, one that does not. So since we are solving for x, what you want to do at this point is that anything that has an x in it, you want to bring it over to one side of the equation. Anything that does not have an x in it, put it on the other side. So I am just going to say, let's subtract x ln 3 on each side here, so that I have ln 3 on the left is equal to 2x ln 2 minus x ln 3. We are wanting to solve this for x, so we're going to drop the left-hand side down, and let's factor out x on this right-hand side. So we're going to factor this x out right over there. And when we do so, that's going to leave us with 2 ln 2 minus ln 3. Now all we need to do is divide each side by this right-hand piece here, that 2 ln 2 minus ln 3. so that they cancel on the right-hand side, leaving us with x. And x is equal to this ln 3 over 2 ln 2 minus ln 3. Now that is as far as we can go by hand. We do need to rely on the calculator in order to do the rest of the workforce here. When we do plug this into the calculator though, rounding to 3 decimal places, we do get a 3.819 is our solution there. Now, before moving on to solving logarithmic equations, let's play around with this equation that we have right over here. We have e to the 2x minus 4e to the x minus 5 is equal to 0. Now, this particular exponential equation does not follow either one of the previous two forms that I mentioned. We cannot solve this using the same base rule or simply by taking the log of each side here. But this equation hopefully does remind you of something. It reminds me of a quadratic equation. And one of the best ways to solve a quadratic equation, I think, is to solve a quadratic equation by factoring. That's actually what we're going to try and do with this equation here. We're going to solve this exponential equation by using a u substitution, by getting this in proper quadratic form here. So what we're going to actually do is I want to substitute something so that I can plug in for e to the x and then e to the 2x. The substitution that's going to allow me to do that is to say that u is equal to e to the x. That means u squared, which is this term here, right? If I do u squared, if I square each side of this, u squared is u squared. If I square e to the x, that is e to the 2x, which works out perfectly for me because this is going to be my squared term. This is going to be my x to the first term to perfectly line up with a quadratic equation. That means e to the 2x is equal to u squared minus 4e to the x, which we just said is a u, minus 5 is equal to 0. So by using this u substitution, we're able to take this exponential equation, convert it into this quadratic equation so that we can factor and solve this equation here. Now this we can definitely factor and solve. So when we factor this out, we know u times u is u squared. Factors of 5 that add or subtract to get a 4 is going to be 1 times a 5, with that 5 being negative, the 1 being positive. So that means when we split and solve here, right, split your factors up, set them each equal to 0. We get that u is equal to a negative 1 and u is equal to a positive 5. I'm sorry. That should be a minus right over there. So yes, u is a negative 1 and u is a positive 5 there. So because we did a substitution here in the beginning, we do need to substitute here back in the end. So we said that u is e to the x. So we now have e to the x is equal to negative 1. And then we have e to the x is equal to a 5. What we want to do with those two equations is we want to solve them for x. And now we can use our second technique of solving an exponential equation by taking the natural log of each side. Using one of our log properties here, ln of e to the anything, kind of think about it, ln and e cancels, and you're left with e is equal of ln of negative 1. Same thing over here, ln and e are going to cancel, leaving us with x is equal to ln of 5. Throw those into the calculator. Whenever we calculate ln of 5, we get approximately a 1.609. Natural log of a negative number. We cannot take the natural log of a negative number. Anytime we are left with a negative value, we cannot calculate that. So for this example, we only have one solution, approximately 1.609. Now, there are two main techniques on how to solve a logarithmic equation. The first by using the definition of logs that looks like this. So most people are familiar with this. It's the first way, it's one of the first properties of logs that you were taught. It also helps us on how to convert back and forth between logarithmic and exponential form. So, the first technique in solving logarithmic equations, you do want to get your logarithmic expression completely by itself in your equation, and then just convert it on over to exponential. So if we take a look at this example, so we want to get our log by itself. So for us, that's going to be the ln x. So let's start by subtracting that 1 on each side, giving us 2 ln x is equal to a 3. Let's divide each side by a 2 to get ln x is equal to 3/2. We then need to solve this here. So we are going to solve this. Just think about it here. We're going to convert that to exponential. So if you have the natural log, the base for the natural log is understood to be an e. So when we convert to exponential, we really have e to the 3/2 is equal to the x here. All right, so all we need to do is throw that into our calculator, e to the 3/2. Again, remember, e is just equal to 2.71, so and so and so. So type that into your calculator, and x is approximately equal to 4.48. Taking a look at our next example, so we want to solve the following logarithmic equation here. So the first thing that I see is that we have multiple expressions here. ln x plus 5, ln x plus 1, ln x minus 1. So do understand that these do all have the same basis here. So what we're going to do is we're going to use a combination of rules here. But first, we need to clean up our problem. If you have multiple logs on one side, you want to use your product, quotient, power rules to condense that down. Now, we have a plus sign here, which correlates to our product rule for logs that says that we can combine these into a single log by multiplying them together. So now I have ln of x plus 5 times x plus 1 is equal to ln of x minus 1. Once we have a single log on each side, we can actually go back to our original properties here and use the same base rule for logs. The same base rules for logs says that if you have a log on either side with the same bases, you can set their x components equal to each other. So for us, this is natural log that's understood to have a base e, natural log understood to have a base e. So that means we can just set the x plus 5 times the x plus 1 equal to that x minus 1. Solve this equation. Now we can solve this equation. First, multiply out that left-hand side, distribute, FOIL, whatever your preferred method of multiplying is. When you multiply that out, you will get an x squared plus 1x plus 5x. So we actually get a plus 6x plus that 5 there is equal to the right-hand side, which is an x minus 1. We are looking at solving a quadratic equation here. So at this point, move everything over to one side so that our equation is in proper quadratic form so that we can work on solving this. So I'm going to go ahead and write that up here. So we had x squared. Subtracting this x now makes that a 5x, then plus a 6 for our equation to solve. Try and factor this problem here. When we factor it, x times x is x squared. Factors of 6 that add or subtract to get us a 5 here. Well, we're going to use the 2 and the 3 because we do want our signs to be positive. That means x is equal to a negative 2 and x is equal to a negative 3. Now, typically that would be okay in a regular quadratic equation, but we're solving a logarithmic quadratic equation where we cannot have negatives for our solutions. That means both of our solutions there do not work out because, again, they cannot equal to negative numbers, which means this is a no solution. All right, so let's see what we're looking at in our next example here. So let's see, we have log base 3 of x minus 8 plus log base 3 of x is equal to a 2. So I see that I have two logs on the left-hand side, and I can combine those two logs into one by using my product rule here. Right? If there's a plus sign in between, that means we are using the product rule for logs, so we can join them into one by multiplication. Now, at this point here, once we have them into a single log, we are actually going to convert this to exponential. We only have one log in the problem, so we do want to convert this to exponential. Typically, if you have a log on either side, you're going to want to try and condense this and use the same base rule. But if you only have one single log, go ahead and convert it to exponential and see what you're looking at. When we convert this to exponential, that would be 3 to the second power is equal to this multiplication here. Solve this equation. So cleaning this up, multiply the right-hand side, simplify out that left-hand side. 3 squared is equal to 9. And when I multiply this out, x times x squared is x cubed, minus that x times that 8 to get a negative 8x. Subtract that 9 on each side, and that is going to leave us with a quadratic equation. 0 is equal to x squared minus 8x minus 9. Factor this out. When we factor this out, x times x is x squared. 9 times 1 gives us an 8 there, with a minus on the 9 and a plus on the 1. That means when we split and solve, we're going to get that x is equal to a 9 and x is equal to a negative 1. Automatically throw out your negative solutions there, and x is equal to a 9. All right, so final example here. Let's solve the following logarithmic equation here. So I do see that I have 2 logs on the left-hand side. So I'm going to do the same thing as the last problem, and I'm going to go ahead and use my rules for logs and condense these down into a single log. So that's going to be log base 4. We have a subtraction going on, so that does tell me we are using our quotient rule. So that's going to be the square root of the x plus 3 divided by the square root of the 2x minus 1. Keep in mind, if you have a minus sign, that's going to correlate to a division there when you use your log rules there. Once we have everything condensed into a single log, we have one log, a log on one side, which is kind of a hint to use the technique of converting to exponential, just like the last problem. When we convert this to exponential, this is 4 to the 1/4 power is equal to the square root of x plus 3 over 2x minus 1. Now, this is the equation that we need to solve. So, solving this equation, the first thing I'm going to do is get rid of the square root, and let's square each side. The left-hand side, you can throw that to that calculator, or if you just do 1/4 of a 2 there, that is actually a half. So this is just 4 to the 1/2 power, which is really just square root of 2 there on the left-hand side. We should get left with a 2 on this left-hand side. I'll simplify that here in the next step. But otherwise, you have an exponent to an exponent, multiply these numbers together to get the 1/2. On the right-hand side, square root and square goes away, and we're left with an x plus 3 over a 2x minus 1. At this point here, so I'm going to go ahead, we do have, this is the square root of 4, or just in your calculator, 4 to 1/2 is equal to a 2. So this is the equation that we are looking at solving. There's multiple ways that you can solve this equation here. You can cross multiply, which is essentially what we're going to do here. On the right-hand side, this is a division. To undo any division, we are going to multiply. So we're going to multiply by the denominator. So this and this cancels, leaving us with x plus 3. And on the left-hand side, go ahead and multiply that out. 2 times 2x is a 4x. And 2 times that minus 1 gives us a minus 2 there. Solve this for x. So subtract x on each side, add 2 on each side to get 3x is equal to a 5. Or when we divide out the coefficient, we get that x is equal to a 5/3.